Building on the basic definition of a probability tree diagram, we have this representation of a probability tree diagram. But this probability tree diagram has a little bit more detail in it. And this extra detail is put in there on purpose so that you have kind of a visual reference for things that we're going to be explaining. Probability tree diagrams are not only good for mapping out the structure of multiple experiments in probability, but it's also useful to learn about probability rules. And so in calculating probabilities of multiple events across multiple experiments even, there are two basic rules. There's the multiplication rule and the addition rule. Both are included in this tree diagram so that these abstract ideas about multiplying and adding probabilities can now be seen in a concrete sense on the page. So let's begin. With probability trees, one generally applies the multiplication rule along the path of connecting branches and the addition rule between resulting outcomes. So let's look at this diagram a little bit more in full. So what we have here is very much like what we've had before. So here, this number 1 represents our first experiment or our first coin flip. 2 represents our second coin flip, and 3 represents our third coin flip. And we're using a capital H to represent the event of a heads, and we're using a capital T to represent the event of tails. So when it comes to probabilities, there's two keywords to look out for. The first keyword is the word and. And the word and, when it comes to probabilities, is talking about the intersection of events. And the mathematical symbol for representing intersection looks like an upside down capital U. And so if you wanted to calculate the probability of getting heads the first time and getting heads a second time, that's equal to the probability of heads times the probability of heads again. And so there's multiplication here between the two probabilities. And that's why this is called the multiplication rule. Now, the other key word to look out for is the word or. And the word or means a union of events. And the mathematical symbol that represents or union is easier to remember. It just looks like a capital U. And so if you're interested in calculating the probability of getting heads or tails, then that would be equal to the probability of heads plus the probability of tails. So this addition of the probabilities is why this is called the addition rule. And so for both the multiplication rule and the addition rule, the literal word and or, are substituted interchangeably with their respective mathematical symbols to mean the same thing. So I will use kind of the two interchangeably during my explanation. Okay, so let's return to our tree diagram. So here in the tree diagram, we're starting our experiment with the first coin flip. And with a coin flip, we could get heads or we could get tails. But now, in the middle of these two outcome branches, we've now included the probability of going down that path. So here we've got the probability of going down the heads branch, and here we've got the probability of going down the tails branch. And then at the second coin flip, we could have as an outcome heads or tails, but now we're also putting in the probability of going down that branch. Now this probability on this second coin flip looks different from the first probability. And the reason for that is this second probability needs to represent the history of the first coin flip happening. And you'll notice that in this diagram, I've set up the events H and T here in red because this is the first coin flip. And then I've put H and T in green for the second coin flip. And I've put H and T in blue for the third coin flip. This may not show up on your notes if they are printed in black and white. So that's why it's good that you're able to see this video in color. So this probability, this second one, is the probability of getting heads a second time given the probability of getting heads the first time. And so whenever you see the probability of two events separated by a vertical bar, that is what's called conditional probability. And that vertical bar between the events is the word given. So the probability of heads given heads has already occurred. So in later problems, when you're being tasked with coming up with a conditional probability, you can determine that by looking at this tree diagram. But let's save that for later, and let's focus more on the multiplication rule and the addition rule. So we started with the first coin flip being heads, and then the second coin flip, just for the sake of argument, also being heads. And so at the third coin flip, we can have heads and we can have tails. And you can see here we've got the conditional probability for that history of 3 coin flips. And down here at the bottom, if we were to trace down this path of getting 3 heads in 3 coin flips, we have down here at the bottom the probability of heads and heads and heads. So the probability of getting 3 heads. And remember, when we've got this little intersect symbol, that's the word and, or the multiplication rule. So whenever you're tracing down a path, whenever you're tracing down a path in a tree diagram, you're multiplying the probabilities down to the bottom. And so that's why I've got the multiplication rule here and the word and. And you can see as we trace down another path, so let's say instead of getting heads first, we got tails in the first flip, heads in the second flip, and then tails in the third flip. That's the probability of tails and heads and tails. So we just multiply those 3 probabilities together to get the resultant probability of getting tails, heads, and tails. So that's how the multiplication rule is defined in a tree diagram. You just multiply the probabilities across connecting branches. Now, where the addition rule takes place is, let's say we were interested not in one specific outcome, but let's say we were interested in only getting one tail, and we don't care how we get one tail. So we could get one tail in 3 coin flips by getting 2 heads and then a tail, or getting heads first, tails in the second flip, and heads in the third flip, or tails in the first flip and heads in the second and third. And so because we don't really care about where the tail occurs, either in the first, second, or third, that's where we use the word or. And when we use the word or, we mean addition. So what we would do is we would add the probabilities of heads, heads, and tails, heads, tails, and heads, with tails, heads, and heads. So by adding these 3 probabilities together, that'll give you the probability of getting at least one tail. So you see, we use the addition rule across the bottom of the resultant outcomes, and we use the multiplication rule down the branches.